Hey everyone, it's your math teacher, Mr. Boyden, back at it again today. Today we're going to be changing gears a little bit. We've spent a lot of time talking about triangles, but we're going to switch it up, and today we're going to talk about quadrilaterals. First thing to notice about the word quadrilateral, it starts with quad. You know what that means, don't you? It means four. Okay, and so these are going to be four. Lateral means sides. These are going to be four-sided shapes. We have a bunch of examples down here. Now, to get us thinking today, let's start by trying to figure out the names of each of these. So what I'd like you to do, I'm going to put these figures up on the board. I'd like you to pause the video, and I want you to try to write down the name of each of these, and we'll see what you already know, and then we'll try to build up upon your prior knowledge. I do need to warn you, there is an extra shape down here at the bottom, so we're going to look at these five, and then I'm going to move down so you can see them. So pause the video, try to write down the names of all these shapes. Okay, and here's the last one if you didn't get a chance to see it. So if you know the name of that, go ahead and write it down. If you don't, take a guess. Do your best. Okay, now let's talk about what they are. Okay, the one that a lot of people get right off the bat that they know is this one right here as a rectangle. It turns out there's a bunch of other names that are also appropriate for this shape, so we're going to look at those in just a second. Okay, let's go back up to the top. Remember these markings? Remember what they say? They're arrows, not tick marks. So these are indicating that our side lengths are parallel. So these two sides are parallel, these opposite sides. The other pair of opposite sides are parallel, and that's why we call this a parallelogram. Okay, so maybe it would be good to take a minute and look down below and see if we notice any other parallelograms. Like, for example, is a rectangle a parallelogram? Are the opposite sides parallel? Absolutely. So I'm going to add here, this is also a parallelogram. What about this shape? Is this shape a parallelogram? Yeah, and rather than having you watch me write the word parallelogram over and over, I'm just going to put a little P over here so we can remember that's a parallelogram. What about this shape? Are the opposite sides parallel? Yeah, you bet they are. Hey, let's look at all of our shapes. What about this shape? Are the opposite sides parallel? So for example, look at this one right here and that one right there. Are those parallel? Not quite. They're not quite parallel, so that's not a parallelogram. And what about down here? Hey, look at these markings right here. Parallel? But what about the other two sides? Now remember, in a parallelogram, we need two pairs of parallel sides. And this side and that side, don't think they're parallel. Okay, so now that we've identified our parallelograms, let's see what other names we know. This second shape, notice these four marks, all four sides are the same length, okay? A lot of people call this a diamond, but it's actually a rhombus. Okay, down here, I bet you know that this is a square. But what else is it? We already said it's a parallelogram. Let's go down our list. Is this also a rhombus? I'm not sure. Maybe we better define a rhombus, okay? So four congruent sides is what we're going to say makes a rhombus. And parallelogram, two pairs of parallel sides. Sides. Cool. Okay, so let's come back down here. A rhombus has four congruent sides. Does this have four congruent sides? Yeah. So I'm going to put an R here, or I'm going to put an RH so we know it's a rhombus. A rectangle. We never really put a definition of a rectangle. Okay, so look at what the features are here. All the information we had was that we had four right angles. Guys, that's going to be our definition of a rectangle. It's going to have four 90-degree angles. And that's not 490, it means four angles of 90 degrees. So look at this. This has the same markings. This is also a rectangle. I'm going to put REC there for rectangle. Okay, so those are looking really good. Let's keep going. What did you put for this shape that's next? This is actually what's called a kite. And notice it's a little different than all the other shapes. It has no parallel sides. And I'm going to use the symbol for parallel this time. It's two vertical lines. No parallel sides. And it has two pairs of adjacent congruent angles. Congruent angles. Okay, now remember, adjacent means next to. So see, this side and that side are next to each other. That's what we mean by adjacent. Opposite would be across from. Notice the opposite sides are not congruent. Okay, and this last shape, that's called a trapezoid. Okay, and the way we're going to define that for this class is a trapezoid has one pair of parallel sides. One pair of parallel sides. Okay, so those are the shapes that we're going to be learning about in this unit. We're going to get all kinds of facts and all kinds of information about them. So let's dive into it and see what we can figure out. Okay, let's start here. Okay, we're going to have our special quadrilateral. They tell us in the question that we have a parallelogram, and we're going to find the length of each side, and we've got some algebra here. So go ahead and pause the video, make your notes look really nice, get this picture down. Maybe you want to even try it. Okay, so when you're ready, let's start by picking one of the sides. It doesn't matter which one we pick. I'm going to pick this one right here just for now. And I'm going to go back and I'm going to look at the picture of the parallelogram we had just a minute ago. In fact, I'm going to make that a little bit bigger so we can see it a little bit more easily. Okay, and so the side that I just picked on the exercise was that one right here. And so what I want you to look for is, do you see any other sides on this parallelogram that look like they might be the same length? Like, for example, if this is a 7, do you see any other places on this parallelogram you might have a 7? Like, is that also 7? No. We can see that that's a different length. Okay, this one is going to be congruent. So it has two pairs of parallel sides, and you can add this to your notes. And opposite sides are congruent. So now, once we have that, let's go back to the question that we're working on, and let's use that fact. Our opposite sides are congruent, which means that this is the same as that. So let's write an equation and solve it. So we get 5a plus 4 equals 3a plus 8. And now we're going to do some algebra steps. Folks, pause the video. Try this on your own. You're not necessarily going to get a lot better by just watching me do it. You have to actually engage with it and try it. So pause the video and try it. When you're ready, hit play, because here I go. So I'm going to go minus 3a on both sides. And I'm going to go minus 4 on both sides. I get 2a equals 4. So a equals 2. Wonderful. Find the value of the variables. I have one of the variables, but there's another variable. So guys, now that you've seen an example, pause the video and you try to figure out how to find b. When you're ready, hit play. Here I go. Okay, I know that 3b plus 2 is the same as the opposite side. So 2 marks is the same as 4b minus 2. Let's do a little bit of algebra. Minus 3b plus 2 plus 2. We're going to cancel those. 4b minus 3b is b, and 2 plus 2 is 4. We always want to go back and read the question. That's been getting some of us in trouble a little bit lately, so let's go back and look. Then find the length of the sides. Aha, so we're not done yet. We found a and b, but we're not done. Let's go back and plug them in. So I'm going to plug in 3. I'm not going to write a, because a is 2. So 3 times 2 plus 8, that would be 6 plus 8, and that is 14. Awesome. Let's check and see if our answer is right. We'll plug it in over here as well. 5 times 2 plus 4 is also 14. Okay, so I feel pretty good about that. Now let's find the b's. So I get 3 times 4 plus 2. Looks like that's 12 plus 2. That's also 14. And I get 4 times b, so 4 times 4 minus 2, which is also 14. Okay, 14, 14, 14, 14. Hey, you know what? This was a parallelogram, but what's another name for it? If all the sides are the same length. If you don't remember, look back in your notes. This is also a rhombus we just proved. Okay, and they didn't ask for that. We're just kind of making connections as we go, though, okay? So with that, let's try another example. Okay, and this one, again, y'all get to try it first and then hit play. So pause your video, give your best effort, and then follow along with me and see how you did. Okay. It does not say, we're going to assume, based on what we've been learning, that this is a parallelogram. Okay, in a parallelogram, we know the opposite sides are congruent, so 3x minus 15 equals 2x plus 3. Let's practice our algebra steps. So plus 15, that's a plus, sorry about my penmanship, and I get a minus 2x, and I get a minus 2x, canceling, 3 plus 15 is 18, x equals 18. Hey, that was quick. Let's plug that back in and see what we get. So 2 times 18 plus 3, okay? I think that's 39, and we get 3 times 18 minus 15, and that's also 39, okay? Solve for x, check, we did that. Give the side measurements, did that as well, okay? So now we feel really, really good. That's all done. Okay. Let's add on to that a little bit with a new piece of vocab. You'll want to add this word diagonals into your notes. And a lot of people realize that diagonal normally means that. And it goes kind of not straight up and down, not vertical, not left and right. It's not horizontal. It is diagonal. In some ways that's useful, but I kind of want you to remember on this, a word that might be helpful is the word across. If you realize that a diagonal goes across something, so like example, if I draw the classroom and I'm standing here in the front of the classroom and I want to move diagonally across the room, I think you'd know not to go like this or like that. You say, oh, move diagonally like that. That's a better way of understanding what diagonal is, because then it'll apply to all shapes. So for us, if we're here at point A and we want to move diagonally on the shape, we're not going to go to D. Now I know, you go, well, wait, but that's diagonal. It's left and right and up and down. However, just like in the classroom, we wouldn't move along a wall to move diagonally. We'd go across the middle of the shape. So you need to do the same thing here, okay? And then from B to D. These are diagonals, okay? Now that we know what a diagonal is, I want you to pay attention again as I draw these in. And what I want you to look for is if these are the same length or if they're different lengths. Is it true that the distance from A to C is the same as the distance from A to B? I don't think so. No, I don't think the diagonals are congruent. In fact, it's pretty clear to me that the distance from D to C is greater than the distance from A to C. But let's notice what is true. Like for example, if I say that from A to this point, I think I'll call it F. If I say that AF equals 3, can you figure out any other lengths on this page that are also 3? Just visually, because we're not proving anything. We're just trying to generate a visual understanding. Like, for example, is this 3 also? Is this 3 also? No, that's way too big. But this is 3. And what if I put a 7 here? What if I say that BF is 7? And guys, I'm just making these numbers up, by the way, just to help you see a concept. If I say that's 7, what else on this picture is 7? Like, is B to A 7? You can imagine if point F swung up, it wouldn't quite reach it there. No, it's not that. Looks like BC is shorter than 7, but you know what? This one is 7. So here's the point. We need to know that the diagonals of a parallelogram bisect one another. Now remember, that means bisect. It means to cut them in half. And we can see that here, because we can see that this diagonal from B to D got cut in half into 2 equal pieces of 7, and A to C got cut in half to 2 equal pieces of 3. So we can see they cut each other in half. One quick check-in, guys, if I put a 10 right here, do you know where else on this picture there is another side length of 10? Okay, we talked about this earlier. Remember, opposite sides are congruent, so those would both be 10, just like our last 2 examples. Now let's apply that learning to this. Okay, go ahead and pause the video, get your picture. All right, so let's start finding things that are equal. Like for example, I'm going to start with x plus 1. Okay, x plus 1 goes from B to E. Now it's really natural. People want to pick 2x. Y'all, you cannot pick 2x because we can even see that E to C right here, that's longer than B to E, so they're not equal. But y is the same length, or E to D. So we're going to say that equals y. And then, okay, we've used those up. Now I'm going to pick on 3y minus 7. 3y minus 7. What's the same as 3y minus 7? Same as this length? That would be this length over here. So that's equal to 2x. Now, notice that both of these equations, each one of them has x and y and x. They have 2 variables, and that makes this a little bit more difficult. So I want to show you an algebraic trick. Make sure you take awesome notes on this, because I think it's something that you can learn, but you'll need to take really good notes, and you may need to come and visit me and ask some questions. So here's what I'm going to do. I'm going to pick the equation that's solved for y. And I'm going to take this stuff that's the same as y, and I'm going to move that over here and write it instead of y. Now we've practiced this a lot, plugging in numbers. In fact, we did it today, right here. We found that x was 18. we then plugged 18 in instead of x. So this is the exact same concept. The only difference is we are plugging in an expression instead of a number. So here's what it's going to look like. I'm going to go 3. I'm not going to write the letter y. Y is the same as x plus 1. So I'm going to put x plus 1 instead. Okay, and then I'm going to rewrite everything else. Minus 7 equals 2x. And for a lot of people, that looks more challenging, but I want to convince you that it's easier because look at how many different variables we now have in our equation. X and x. Hey, that's only one variable. That means we can be successful in solving this. So let's do it. We need to distribute. So we get 3x plus 3 minus 7 equals 2x. And from here, you can do whatever feels most natural to you. What feels most natural to me is doing 3 minus 7, and that's negative 4. Just combining like terms. I get 3x and equals 2x. I can go minus 2x on both sides. So I get x minus 4 equals, what's that? Something minus itself? That's 0. Make sure you put the placeholder. Plus 4 on both sides, and I get x equals 4. Okay. Solve for x and y. Solve for x, need y. Now, some people, and I was one of these back when I was learning this, by the way, I'd get really frustrated after they say, but look, I did all this great work. I don't want to find more stuff. That was a lot of work. I'm only halfway done. It's okay. We're a lot more than halfway done. Watch this. We know that x is 4. We have an equation right here that tells us how to find y. So it says x plus 1. I know that x is 4. So that would be 4 plus 1 equals y. And I'm assuming, since you're a high schooler, you could probably figure out that 4 plus 1 is 5. So because you see how quick that was? Once you have one piece of information, it almost always is a lot quicker to find the second piece. So they asked us to solve for x and y. Solve for x, solve for y. Hey, we did it. That's awesome. Good for us. Now we're going to try another one, okay? Because it's after we've tried one, it's good to have practice. If that went too fast, go back, watch it again, fill in your notes, write down questions you have, and then when you're ready, come back to here, pause the video, and try it all by yourself. When you're ready, hit play and see how you did. Okay, here's how it goes. I know that x is the same as 7y minus 16. I know that 5y is the same as 2x plus 5. And then I know that if x is 7y minus 16, I can plug that in for x. So here's what it looks like. 5y equals 2 times 7y minus 16 plus 5. We're going to distribute that, so we get 14y minus 32 plus 5 equals 5y. I'm going to subtract 14y. So I get negative 9y equals, those cancel out, and negative 32 plus 5 is negative 27. So I'm doing two steps in one. Divide by negative 9. So y equals 3. I'm going to plug that back in up here. 7 times 3 minus 16. So x equals, x equals, x equals, that looks like 21 minus 16. So x is 5. Okay, there's y, there's x. Now we're going to practice finding angles. So we're basically going to look at parallelograms from a bunch of different perspectives. We've really focused on sides so far. Now let's focus on angles. Now, this is an exercise that's going to build on a lot of things we've already learned this year. So again, pause the video, draw it, write down as many as you can, and when you're ready, hit play. Okay, first thing I'd want you to notice is that this angle right here is vertical to 100, so that's 100. Down here, you've got a triangle, and we know every triangle has how many degrees? 180. So that's going to be 35, and all I'm doing for that, y'all, is I'm taking 180 minus 100 minus 45, and that gives me 35, and I know that's 35. Next thing I'd want you to look for, or there's a couple things you could look for. One of them is, notice there's 4 main triangles that get created when we make these cuts. And I'm looking at this triangle down on the bottom. Do you see any other triangles that are congruent to that one? Notice if we rotate this bottom triangle 180 degrees, it actually creates triangle QTR. So that indicates that 45 degrees, where is the corresponding part on triangle QTR? Happens up at R, so that's 45, which means the corresponding part to 35 is up here. Or you could understand that since this is a parallelogram, that we're going to have alternate interior angles. 45 and 45 are alternate interior angles. And then finally, we have one straight line here, which means we have a linear pair. Linear pairs also add up to 180. So 100 plus 80 is 180, and 100 plus 80 is 180. Okay, this one, there's a theorem hidden up above, but I'm not telling it to you yet because I want you to try to predict what it is. Notice we've got parallel lines. We have congruent segment markers here. So like if I say this is 5, that one is also 5. And I'd like you to make a prediction. If I decide that this length over here is 7, could you make a prediction for the distance between these 2 points? How long is that segment? Okay, a lot of people say 7. And guys, that's all this is. Okay, that's literally all it is. It's going to say if we have 3 or more parallel lines, notice we do 1, 2, 3. And if they cut off congruent segments on one transversal, there's one congruent segment, there's a second congruent segment. Then they cut off congruent segments on every transversal. So here's our other transversal, and here's our congruent segments that are labeled, because that's all that's going to say. So here's an example of a test style question. And check it out. You've got congruent segments, 2, 2, 2. You've got a 2.5 here, so hey y'all, shout it out loud. What is the length right here? That's 2.5. And what is this one? 2.5. And that's all it is. I think it's more intuitive than the wording sounds. You can almost see that, hey, these are all equal. Guess what? These are going to be equal too. They are proportional because they're similar shapes. All right, y'all, that's enough parallelograms for right now. Hope you enjoyed it, and I'll see you next time.